Assalamualaikum and good day everyone. In this video, we're going to talk about the second category of tools to describe data, which is measures of variation. So there are 5 different tools under this category, which are standard deviation, variance, range, interquartile range, and also coefficient of variation. So in this video, we're going to focus on 3 things, okay? Just like how we did in our previous video, which is to discuss about how does this measures of variation helps you to describe your data, how to do the calculation, and how to do the interpretation. Okay, so first, let's look at the first focus. Okay, let's try to understand what is standard deviation, what is variance, what is range. Okay, so in order to do that, I prepared to you these 2 different data sets. Okay, so let's consider the variable test score. Okay, so this is test scores collected from students in group A and also group B. Alright, so you can see that both group has the same sample size, which is 6. Okay, both group has 6 students. And if you continue to calculate the average value of test score from each group, you will find out that both group has the same average value, which is 66.67 marks. Okay, so now here, what if I ask you which group has better performance? Which one would you choose? Is it group A or is it group B? Is group A better because there is a student who scored highest among all the students here? So is that why group A is better? Or is it group B is better because in group A there is a student who scored very low, which is lower than any of the students in group B? So because of that, does that mean group B is better than group A? Alright, so this is a bit confusing because both group has the same average value. Alright, so because of that, you can't really say which one has better performance, right? So maybe there's another point of view that we need to look at. Okay, let's try to illustrate these data values on a number line like this. Okay, and here is the mean value, 66.67. Now, once you have plotted on a number line like this, you can clearly see that the data values in group A, okay, are far apart from each other. They are spread from each other and they are also far from the mean value. Even though this is the average value, but you can see there are data values who are far from the average value. Alright, so the data in group A is widely spread. Now let's look at group B. In group B, the data values are closer to each other, right? And when they are closer to each other, you can also see that the data values are closer to the average value. Compared to group A, the data values in group B is much closer to the average value, which is 66.67 marks, right? So in this case, you can see that the data values in group B is more consistent compared to the data values in group A, which tells us that, okay, the students' test score in group B, okay, the students in group B, they are more consistent. Their performance is more consistent compared to group A. So in that sense, okay, we can say that group B has better performance compared to group A. So guys, how do you explain this spread and consistency? This is more spread and this is less consistent. Okay, so if you were to illustrate in a number line like this, so yeah, you can easily see whether they are widely spread or whether they are consistent. So another way to see the spreadness or the consistency of data value is by using measures of variation. So this is where measures of variation takes part. Measures of variation are measures that determine the spread of your data values. If your data values are spread from each other, if your data values are far or ataupun spread from the average value, your measures of variation will have a big value. Your measures of variation will have a larger value. If your data are close to each other, if your data values are close to the average value, then you will have a smaller measures of variation. For instance, if you calculate standard deviation, you will find out that the standard deviation of group B is smaller than the standard deviation of group A. So you can use measures of variation to describe the spreadness or the consistency of your data set. Or in other words, it is also what we use to describe the variability of your data set. So this is what? Okay, this is the function of measures of variation. Okay, so let's look at the formula on how to calculate these measures. For range, it is simply the highest value minus the lowest value. For example, here for this data set, you just take 8. 8 is the maximum value here, minus 1, which is the minimum value. So you will get 7 as the range. Okay, range is the simplest measures of variation. It is easily affected by one extremely high or low value. Moving on, this is variance. You don't need to memorize, or you don't need to know how to use this formula, guys. Okay, please remember, class, you can just use your calculator to find your variance and standard deviation. Okay, remember, you must use your calculator to calculate sample variance and sample standard deviation. You don't need to show your calculation in your answer. Alright, so maybe I need to highlight the notation here, okay? So for population variance, it is sigma square. For sample variance, it is S square. For population standard deviation, the notation to use is sigma, and for sample standard deviation, the notation is S. Okay, class? Next, let's take a look at the properties of variance and standard deviation. Now, I do need you all to read on this later. In this video, I'll just highlight 2 points, which are, number 1, variance and standard deviation is always positive value. Remember this, okay? And then, whenever you need to write down variance value in your answer, in your solution, you don't need to write down unit for the calculated value. But for standard deviation, you do need to write down unit. For example, okay, imagine that you have collected a set of data about weight of students, okay, and then you calculated the standard deviation of this data, and maybe you get 10. That's the calculated standard deviation value. So when you want to write down this value on your answer sheet, on your solution, you need to write down the unit. Is it 10 kilogram? Is it 10 grams? Okay, so for standard deviation, you need to write down unit, but for variance, you don't need to write down any unit. Now, moving on to the fourth measures of variation, which is interquartile range. It is the difference between the first and the third quartile of a data set. So basically, the formula for IQR is Q3 minus Q1. So what is Q3 minus Q1? Okay, you might wonder what is this, right? So I will teach you on how to find quartile 3 and quartile 1 of a data set in our next class. Okay, for this video, just take note on the formula for IQR, which is Q3 minus Q1. Now, the properties of IQR is that it can be used as a rough measurement of a variability. So it has the same function as range, standard deviation, and variance. It is not easily affected by outliers, and it is most of the time used to show the variability of a data set which has a skewed distribution. This is very interesting, so I'm going to talk more about this later at the end of this video. For now, let's take a look at the interpretations of range, standard deviation, variance, and IQR. Alright, now let's imagine that you collected 2 sets of data, okay? 2 sets of data from the whole population. You have 2 different populations, population 1, population 2, and then you collected your data from both populations, from all the subjects in both population. And then you calculated the standard deviation. So if let's say the standard deviation of your first population is smaller than the second population, this indicates that your first population is less dispersed, less spread, less variable, more consistent, more precise, more accurate, and better data. Compared to your population 2, okay, your second population, which has a greater value of standard deviation. So if your population 2 has a greater standard deviation value compared to population 1, this indicates that your population 2 is more dispersed, more spread, more variable, less consistent, less precise, less accurate, and worse data. So this is how you interpret measures of variation. When you want to interpret it, you need to tell about the consistency, which one is more consistent, which one is less variable, or which one is more spread. This is the interpretation that you need to use for measures of variation. Okay, is that clear? Why don't we take a look at an example for this? Okay, so look at this. Given to you here is our two data sets, okay, which is the variable here is the age of lecturers, okay, the age in years. Now this is the age of lecturers in phase, and then below here is the age of lecturers in FKE. Obviously, this data is sample data because I'm sure there are more lecturers in phase. It's not just these few people, these few entry. I'm sure that there are more lecturers in phase, but we only collected a few from a few of them. So this is sample data, and this is also sample data from phase and FKE. Now, we can see here that both data sets has different sample size. FIS has smaller sample size compared to FKE, but that does not matter. What we want to do here in this video is that we want to look at the variability. We want to compare the variability of lecturers in FIS and FKE. Okay, the age of lecturers in FIS and FKE. So if you use your calculator to find the sample standard deviation for both data set, you will get this. Okay, for FIS you will get 7.4670 years. Okay, need to write down unit because this is standard deviation. And for FKE, it is 9.9460 years. Obviously, we can see here that FIS has a smaller standard deviation compared to FKE. Remember, if it is smaller, okay, if it is smaller, then it indicates that that population or that sample, it has more consistent, more precise, less variable data. So therefore, here we can say that since standard deviation of FIS is smaller than the standard deviation of FKE, so FIS data is more consistent and less dispersed compared to FKE data. So what does you understand about the lecturer's age? Okay, when you know that FIS is less variable than FKE. So this means that the variation of ages for lecturers in FIS is small and less dispersed as compared to FKE lecturers. In other words, the age gap of lecturers in FIS is smaller compared to the age gap of lecturers in FKE. You see, this is how measures of variation helps you to understand about your data. Okay, it tells you whether your data value are close or whether they are spread from each other. Okay, now we have one more measures of variation to discuss, which is coefficient of variation. Alright, so this is also measures of variation. Okay, the formula is very simple. It's basically just by taking the standard deviation divided by mean and multiply with 100%. Alright, so if your data is from the whole population, so this should be your formula. But if your data is from sample, this should be formula, but both are actually the same thing. It's just that they use different notation because this is parameter and this is statistic. Now, let's go to the properties of CVAR. Okay, the result is expressed as percentage. Yes. Okay, so the unit for CVAR is percent. And then another important properties of CVAR is that it is used to compare the standard deviations or to compare the variability of two datasets that has different units. Okay, it is used to compare the variability of two datasets that is different variable. Okay, what am I talking about here? Now, in this example, I have presented to you two datasets, am I right? So this is age of lecturers in FIS and this is age of lecturers in FKE. Alright, but what if I give you two datasets of different variable? In this slide here, these two datasets are the same variable, which is age. Now, what if you need to compare the variability of two datasets of different variable? For example, here. Okay, let's take a look at this one. Okay, let's read. The average age of the accountants at a huge company is 31 years with a standard deviation of 4 years. The average salary of the accountants is 4,400 for the 4,255 per year with a standard deviation of 780 ringgit Malaysia. Compare the variations of age and income. You see, you're given information about two different variables. One is age and another variable is salary. Okay, age and salary, and they want you to compare the variation between age and the income, which is the salary. So in this case, to compare the variations, to compare the variability, you can't use a range, you can't use standard deviation, you can't use variance or even interquartile range, because age and salary are two different variables. So in this case, what you can use is you can use coefficient of variance. Okay, so this is where coefficient of variance takes part. Okay, this is when we use coefficient of variation. Alright, so you can try to do the calculation here. Just take the standard deviation divided by the mean and you can get this CVAR for age. Okay, again, do the same thing for salary and you will get the CVAR for salary. And this is the answer that you're going to get. 12.90% for age and 1.76% for salary. Okay, now you can compare their variability lah. Alright, you look at the value. Smaller means more consistent. Yes, yeah, you're right. So the salary data is more consistent compared to the age data, since the CVAR for salary is smaller than CVAR of age. Okay, now, so this is what you understand from the calculated value. But what else can you describe about the data? Okay, what else can you describe about age and income when you know that salary is more consistent? Alright, so this means the variation of salary paid to the accountants are more consistent and less variable compared to their age. So this is the interpretation class. Okay, this is the interpretation. This is how you interpret measures of variation. Okay, you need to give a meaningful interpretation about the variable. Or you can also say the age difference between the accountants is bigger compared to their salary difference. Okay, so the interpretation down here is more meaningful compared to just telling us that, oh, data salary is more consistent. Okay, it is more meaningful when you explain that this means that the age difference, okay, the age gap is bigger compared to the salary gap. Am I right? Okay. So remember, if you need to compare the variability between two different variables, you use CVAR. If you need to compare the variability of two data sets which is the same variable, then you can use standard deviation, range, variance, and IQR. Alright, so remember the important properties of CVAR. Please continue to try on some of the exercises provided to you in this slide, or if you have bought the module, there are more exercises, tutorials for you to try on from the module. Okay, now before we end the video here, I would like to elaborate on this important concept. If you were to conduct an experiment or observation, okay, when you collect data from experiment or observation, it is important that you make sure that you test the validity and reliability of your measurements, okay, of your experimental data. What does it mean by validity and reliability? It is also about the concept of accuracy and precision. Accuracy is how close a measured value is to the true measurements. So if your measurements, if your readings is close to your targeted reading, okay, when you conduct an experiment, you must have a targeted value, okay, that you will define it as a true value in your experiment. So if your readings are all very close to the targeted value, then you can say that you have a very accurate reading. That is accuracy. It's about how close is the measured value to the true measurements. On the other hand, precision is about how close the measured value is to each other. Regardless of whether or not it is close to the true measurement, to the targeted value, okay, precision is just about how close is the readings, it's the measured value to each other, or how consistent your results are for the same phenomenon over several measurements. So precision is actually the measures of variation, okay, which must be included lah in your experimental data analysis. Accuracy also must be accounted to see whether it is accurate. Okay, the bigger the difference between the measured and the true values, then it means your machine that you're trying to experiment is less valid, less accurate. Okay, and the smaller the unit, the more precise the measurements. The unit of precision lah, which is your measures of variation. So this is what it means by the smaller the unit. You can also view this like a game of darts. Okay, now imagine that the middle here is your targeted value, or the true measurements that you're trying to get in your experiment. Okay, so if this is your readings, all right, you can see here it's like scattered around the targeted value. Well, we can see that yeah, the readings is close to the target, but they are far from each other. So this is accurate reading and not precise reading. Get it? Okay. And then in picture B, you can see that the readings are far from the target, but they are close to each other. So this means that this readings is, what is it? Yes, it is not accurate, but it is precise. And in picture C, you can see that the readings are scattered away from the target, and it's even away from each other. So this is not accurate and not precise. But in picture D, it shows readings that are very close to the targeted value, and they are also close to each other. So this is very accurate and precise reading. So in an experiment, you would aim to get readings which are accurate and precise. Macam tu. Alright, so yeah, there's still more to talk about, to discuss about this measure, but I think I'm gonna continue that during our virtual class. Alright, so I will stop my video here. I look forward to see you in our class. Thank you for listening in. Assalamualaikum. Have a great day. Bye bye.